Hello, Madam Abuchi, how are you?
Fine, ma. Good evening.
Good evening. What happened? I'm yet to see others. Do you have any other class going on?
No, ma. Maybe they are still resting after their job receipt.
Oh, but jam was in the morning, right?
Yes.
Or some persons took in the afternoon?
Yes, my son.
Okay, should we wait for them for a while? Because this is very important. Let's wait for them for like 4 more minutes. But Mother Abuchi, you received the note I sent yesterday.
Yes, ma.
Did you?
Yes, I did.
Okay. Did you go through the question? Did you try them?
No, ma.
No, you did not. Why?
Due to
Did
the
you go
jam.
to speak to them?
Yes. I receipted for the jam and also my agri practical, both of them.
Oh my God. A lot of things. Hmm. What are we going to do? I was thinking of just taking 30 minutes out of the 2 hours to uh, take your questions in titration calculations and solve some of them that some of you may find difficult. And now they are late. They are coming late. So are you people sure that this 2 hours will be enough to finish everything? Mm.
Yes, it's
It's
very.
remaining 3 minutes. Let's just wait 3 minutes. Once it's 7:10, I'll start. I don't know what else to do.
Good evening, ma.
Good evening, Arulua. How are you?
I'm fine, ma.
Welcome. You people came very late today. Did you also write the exam?
No, ma.
So why did you come late? Hmm?
I almost forgot about the class, and I'm also
Oh,
having network issues.
okay. Did you receive the note I sent yesterday?
Yes, ma. But I couldn't
Okay.
go through it because I was having papers today.
You wrote Agric?
Yes, ma.
Oh, okay. How was it?
It was fine, ma.
Okay. Do you have another paper tomorrow?
No, ma.
Okay.
I don't.
Okay. All right. Let's see. Okay, tomorrow is Saturday, sorry. Tomorrow is Saturday. Anyway, I don't know. I've waited for 10 minutes. I have to move on. I want us to, I thought you would go through the notes I sent you, solve them, then I will know if there is anyone you are having problem with. But since none of you solved this, please, Aroluwa, time me, okay? Once it's 7:40, you let me know.
Okay, ma'am.
So we'll go through what we did yesterday. There are some other questions. I have about 6 questions that we haven't solved yet. 4 and 2 for assignment. So I will just touch the ones I think requires my attention. Then we'll move over to SWOT analysis. Okay.
Okay, ma'am.
Mother, which I hope you are here.
Yes, ma'am, I'm here.
Okay. All right. We stopped at finding the concentration of HCl, and I must apologize for what happened yesterday. Okay. My both laptops were down, and I didn't know. I didn't know that the second one was down. Okay. All right. We stopped at concentration of HCl acid in grams per DMQ. Let me see if I can locate what we got. If you have your note with you, I thought I said that. If you have your note with you, can you tell me what we got here? The value we got here. If you have your note with you, or you have lost the note already. If you have your notes with you,
Ma'am, my
can you
phone was
remind
dead.
me? Okay. You weren't writing the calculations down.
No, ma'am, my phone
Mother,
went off, so I couldn't continue with the class with you guys.
okay, okay,
It was 0.0619.
good. 0.0619. What did we get for the concentration of the base in moles per DMQ? I'm still waiting, Mother Agochi. Or you are solving it just now?
No, I'm not solving it.
I think the base is 0.0619. Then the acid is 0.06 something else.
47.
17. Okay, 47.
0.0647.
Okay. Moles per DMQ. Moles per DMQ. Then the concentration of the acid in grams per DMQ. What did we get? What did we get? Find it for me. Or multiply this by 36.5. Let me know what you have. Multiply 0.60647 by 36.5. 2.36 grams per dm3. All right. Yesterday, I told you that the volume of the acid that we should use 23.95 cm3, and the volume of the base is constant. The pipette we normally use is 25 cm3. If the pipette you have in school is 20 cm3, then your VB is 20 cm3. Okay, but the common one is 25 cm3. All right. Now, the next question says amount in moles of acid used. You know that even though you have the acid in your beaker and you even have some in the burette, you did not use all the acid. You just used a small quantity, that quantity that neutralized the base. So you only use this volume of acid. Are you with me, class?
Yes, ma'am.
Good. You only use this volume of acid, which is 23.95 cm3. That's the volume of acid you used. Then the question says, tell us the amount of acid in moles, amount of the acid used. So you have to find the amount of acid in this small volume, okay? If you have to do that, remember that N is equals to CV. Amount is equals to concentration times volume. If you are using this equation singly, the way it is, where you don't have two different volumes cancelling out, you have to convert this volume to dm3. I've said this several times, okay? If you are using it this way, your volume must be in dm2. But if you are using CAVA over CBVB, you don't need to convert because this volume will cancel out this volume. So the unit will cancel out. That is why we don't normally convert. Even if you convert, you still get the right answer. But it's not necessary, it's time wasting. But if you are using this, where you don't have two volumes canceling out, your V must be in dm3, okay? Now, we know the concentration of the acid. We know the volume of the acid used. Therefore, we can find the mole of the acid used. Okay? So this will give us what, class? I'm waiting for you. Tell us what I should write. Am I alone here?
No, ma'am.
So what should I write?
0.0647
0.0647 multiplied by what? Multiplied by what? Converting cm cube to dm cube is dividing by 1000. So count this thing backward in 3 times. You have 2395. Are you with me?
Yes, ma'am.
Yes, ma'am.
Please, if you have to convert cm cube to dm cube, you divide. But if you are confused, if it is confusing you, please say 1000 cm cube equals to 1 dm cube. So 23.95 cm cube equals to X. Okay? Instead of doing the wrong thing, you still go back here it will give you this. So press your calculator and tell me the answer, please. Let's be fast. Let's be fast.
Zero point zero zero 0.0015.
0.0015. What would be the unit? Is it did it end in 1.5? Nothing after 5?
There are numbers after 5.
Please give me everything in full, because remember, we are meant to leave this in 3 significant figures.
495565.
Okay, 0.00149.
No. 0.001549565.
Okay. 154,956. Right? Okay. To 3 significant figures, we have what? To 3 significant figures, we have what?
0.00155.
Good. 155 mole. Remember, the unit is as important as the answer. No unit minus 1. No unit or wrong unit minus 1. Okay. This is for, okay. Let's go to IV. Amount in moles of sodium hydrogen carbonate used. Please, we have done the amount in moles of acid used. So find the amount in moles of sodium hydrogen carbonate used. Do that for me, because the answer is staring at me. Do that for me. I'm waiting. You have 30 seconds for that.
My got 0.00155 also.
You got 0.
0.00155
mole. Okay. Any different opinion?
Yes, ma'am.
Okay, what did you get?
Just 0.0015475.
0.0015475, right? Is that what you got? Please, I need you to respond. The slower you respond, the slower we go.
Yes.
And the faster our time moves, please.
Yes.
Is this what you got?
Yes, ma'am.
Okay. So that means you got approximately the same thing. 3 significant figure, we have 155 moles. Okay. All right. Who doesn't know how we got this? We use the same formula. Let me write it. IV. We use the same formula. N is equals to CV. We find the concentration of the base. You have the concentration of the base, you have the volume of the base. So you multiply out, you get the same thing. Okay. All right. Now, the next question is mole ratio of the acid to the base. This question is actually unnecessary for the calculation here because we have equation of reaction. But the next question will not, some questions will not have equation of reaction, and they will ask you to find the mole ratio. So that is why I added this here in case you don't even know the acid that reacted, okay? And because of that, you cannot write the equation of reaction. You can be asked to find the mole ratio, and using that, you can predict the acid. So let's see how we can find the mole ratio. Mole ratio of A to B. The mole of A that neutralized B. Okay, let me write them down here. A and B. The mole of A that neutralized B is 0.00155, and the mole of B is 0.00155. So how do we find the ratio? What would be the ratio of A to B? What would be the ratio of A to B? I'm waiting for you.
1:1.
1:1. 1:1. How did you find that? How do you find ratio? You divide through by the smallest number. This divides this to give you 1. If you divide this, will give you 1. So the main ratio is 1:1. Okay? Any question here? All right. Let me look for another question we can solve. Okay. Oh, the only reason I want to solve this is this. Okay, can we do this in 20 minutes, in 10 minutes? 10 minutes. Elizabeth, read the question for us.
A is a
Elizabeth, are you
solution.
here?
Yes, I am.
Okay.
A is a
All right,
solution of
continue.
hydrochloric acid. B is a solution containing 2.45 grams of anhydrous sodium hydrogen trioxocarbonate 4 in 250 centimeter of solution.
Okay.
A. Put A into the burette and titrate it against 20.0 centimeter cube or 25.0 centimeter cube portion of B using methyl orange as an indicator. Repeat the exercise to obtain consistent titers. Tabulate your burette reading and calculate the average volume of A used.
Okay. Now, normally, this is the way the question will come. You do your titration, you tabulate your reading, okay? And then you write the volume of acid. The first question is concentration of B in moles per dm³. So we have to write out the parameters we have in the question. The volume of the acid. Let's assume you have done your titration and you find out that the average volume of acid used is 23.95 cm³. Average volume, okay? I'm just using, we are going to use this throughout so that it's easy for us to trace where the problem comes. So VA is 23.95. I don't know why I like 29. 23.95 cm. Then the volume of base, tell me the volume of base, class. The volume of base used.
5.
What?
25.
25 cm3. Very good. Now, in the question, we don't know the concentration of the acid. And 2, we don't know the molar concentration of the acid. That's the concentration of the acid in moles per dm³. We don't know that. That's what we call molar concentration. 2, we don't know the molar concentration of the base, but we know the mass of the base that dissolved in 250 cm3. So we can find the mass concentration of the base. If we have the mass concentration of the base, then we can find the molar concentration of the base. Unless you do this, you won't be able to find molar concentration of the base. You need to find the mass concentration first before you find the mole concentration, because we don't have that of acid with which we can compare. So because of that, the first question says concentration of B in moles per dm³. So first, find C in grams per dm³. Find concentration in grams per dm³. So this is exactly what we did yesterday. So do that for me. What formula did we use yesterday? Gram concentration is equals to what? I'm waiting for them. Concentration in grams per dm³ is equals to what, class? I really don't know why you should keep quiet at this point, because you know what concentration means. Concentration means the quantity of a substance in a given volume. If you are looking for molar concentration, that's concentration in moles per dm³, then your quantity should be mole and your volume in dm³. If you are looking for concentration in grams per dm³, then your quantity should be mass and the volume in dm³. I don't know why you should keep quiet at this point. We did concentration during your JAMB class. So concentration in grams per dm³ is equals to mass over volume. Your volume in dm³. Okay, Oroluwa got 0.178. Okay. Please, any different opinion? Oroluwa, is it the mass concentration that you got?
No, ma, the molar concentration.
Okay. So let's solve this. Mass concentration is equals to the mass that dissolved, 2.5. Is it 2.5? 2.45 over the volume is 250 in dm³, 0.250. So give me the answer you got, Oroluwa, for gram concentration.
9.6.
9.6 grams per dm³. So at this point, we can find the molar concentration of the base. Let me scroll down a little. Molar concentration of the base. Remember, we are still doing I, okay? Remember, mole per dm³, mole per dm³ is equals to gram per dm³ over molar mass. That is, molar concentration is equals to mass concentration over molar mass, okay? Any confusion, class?
No, ma.
Before they were. Let me write it here before they will attack me with questions in moles per dm cube is equals to. Okay. 9.6 over 84. Before then, we did this yesterday. Calculate the molar mass of sodium hydrogen carbonate. Okay, this will give us 0. What?
1142.
1146, right?
2.
1142. Approximately 0.114 moles per dm cube. Arolua, is it the same as yours?
No, ma'am. I'm trying to find out what my error is.
Okay. Madabuchi,
Yes, ma'am.
is this the step you took?
Yes, ma'am.
Okay.
Her fault may be in her molar mass.
Okay. 23 plus 1 plus 12 plus 16 times 3. This must be in brackets. If not, your calculation will be messed up. 16 times 3 must be in brackets. All right, let's move to question 2. Question 2. II. Calculate molar concentration of A. Do that in 1 second. We have 4 minutes remaining for me to move to. Now, I needed to do some calculations in titration. There are some calculations we need to do. Okay, I need your answer for the second one. Molar concentration of the acid.
Scroll down. Let's see the question.
What?
Scroll down. Let's see
The question.
Yes.
Okay. Is that taken? So find the molar.
The volume of B.
What is the volume of what?
Okay, we should use 23.95. Volume of B.
Yes.
Volume of A, sorry.
A is 23.95. That's the average volume of acid used. Some people are not saying anything here. Let me check. Edith, I've not heard your voice. Ademola, I've not heard from you. Elizabeth, I've heard from you, but I'm still waiting to hear more. Habibat, welcome, Habibat. I need to hear from you too. So the concentration of A in moles per dm cube, give me the answer.
I got 0.238 mole per dm cube.
0.238 moles per dm cube. Okay.
0.6.
I need a different
0.067 mole per dm cube. 0.067 mole per dm cube.
Okay, 0.067 mole per dm cube. Okay, any other opinion? So what actually brought about this discrepancy? Let's see. We are looking for CA. So CA is equals to CB, VB, NA over
My God.
V. Okay, you got what?
0.1129.
1129. Okay, we shall find out who got this, where the mistake is coming from. NB.
Ma, I got
Yes.
0.0595.
0 point what?
I 0.0595.
0.0595. Okay, let's see. Let's see. Our CB. Please, do you all agree that CB is 0.114? Let's move it down. Do you agree?
Yes, ma'am.
0.263.
I'm talking of CB. CB, the one we did first. 0 point.
Yes, ma'am.
Okay. So 0.114 multiplied by 25 multiplied by 1 all over VA is 23.95 multiplied by 1. So if you all did this, then where is the confusion coming from? 0.114 times 25 times 1 over 23.95.
The
If
answer
this
is 0.119.
0.118979, approximately 0.119. So where did all these figures you gave me came from?
Was it
Class,
that I
can you tell me what the problem is?
this is the format I use.
This is the format you used,
Yes, ma. Let me
and you
punch my
got a
calculator
different
again.
thing.
I got 0.11. Let me punch it again.
If your substitution is correct, you should get the same thing, unless something is wrong with either your punching or your substitution. So check the
I
numbers.
I used the wrong number of mole.
Okay, please, NaNB is the number of moles from the equation of reaction. It is 1:1, is it not?
Yes,
Look at,
ma'am.
Ma, the reason is that I
I
added 2 to that
okay,
to
okay,
CB.
okay. I've seen the problem. This, ba?
I added 2 to CB. I punched 0.1142 instead of 0.114.
Okay, okay. But that shouldn't make the answer too far away. What did you get?
I got, look at, you wrote it there, 0.1129 and so
Okay,
on.
okay, 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 okay. All right, all right. Okay, please. The ratio is 1:1. This 2 here is wrong, please. The ratio is 1:1. Acid to base is 1:1. Because forgive me for that mistake. But we've been doing
Okay.
this now. You should know it's 1:1. All right, let's go to the last one. Volume of, okay, no. All right, find I. That one is straightforward. Concentration of the acid in grams per dm cube. Find that one first. The reason why I'm doing this is because of number 4. So be fast about number 3, please.
Ma, please can you scroll up a little?
Okay.
No, like
Down.
the one we finished solving so that it will show.
Okay. Okay.
Yes, ma. Thank you, ma.
You're welcome. Please, I'm going to stop in this question. I have other questions. Please make sure you finish all of them. If you have any question, you can send the question through the admin. Okay. I don't mind making a video of your question and answering the question. Okay. Please, you need to, because I have different questions that can come out in this titration. I'm waiting for your response, please. Concentration of the acid in grams per dm³. Why is it taking so long? You know the mole per dm³. So the acid is HCl. So molar mass 36.5. So why is it taking long? Why is this taking long? Your response, please. Your response, please. I am waiting for you. If you want us to wait forever, we'll wait forever. Give me the answer to
My
this question. Okay. I'm waiting. If you're ready, you let me know.
had
I got
4.344
4.344 gram
gram
per
per
dm.
Good. 4.34 grams per dm³. Okay. Any different opinion? Any
No,
different
ma.
opinion? Okay. So the last question, IV, said the volume of gas evolved in the reaction at STP. What gas was released in this reaction? Is the equation of reaction. Let me write it clearly one place so that you will always refer to it. The equation of reaction is HCl plus sodium hydrogen carbonate. This will give you sodium chloride plus water plus CO2. You balance the equation. So the equation is balanced. That is why I'm going to leave it like this. The equation is balanced. So the question is the volume of the gas evolved at STP. First of all, you have to know the number of moles of the gas evolved at STP. With that, you will know the volume of the gas evolved. Okay? According to the equation of reaction, 1 mole of the acid will release 1 mole of CO2. Am I correct?
Yes, ma'am.
That is according to the equation, okay? But the acid, the number of mole of the acid that reacted is not 1 mole. What mole of the acid reacted, please? Can someone find out for me? We have done it somewhere. Can someone find it for me? The mole of the, okay, we did not do it here. It's in the first question. Find the mole of the acid that reacted, please. You see? This is the question you need to answer before you find this. Find the mole of the acid that actually neutralized that base. I'm waiting for you. We've done similar question in the previous number. I'm waiting. The mole of the acid that reacted. Don't forget the volume of the acid is 23.95. Don't forget that. cm. So I'm waiting for you. Any opinion? The mole of the acid that reacted.
I got 0.00143.
0.00143. Okay. All right. 0.00143. 0.00143. Okay, we shall find out. All right. I'm waiting for a response while I do this. Remember, number of mole is equal to concentration times volume. So number of mole of the acid is equal to concentration of the acid, which is 0.119. Is this what you did? Times volume 0.02395.
Yes, ma'am.
Very good. And you punched your calculator well, because that is not what I got when I punched mine. Please let calculator not be your problem that day. 0.119 times 0.02395 will not give you 0.0014. Please press your calculator.
0.00285.
So what happened? What happened? Please be careful. You already know this, so why will it be calculated? That will be your problem. So approximately 0.0285 moles. Okay. Now the question is the volume of carbon dioxide. 0.0285 mole. Remember, from our reaction, 1 mole of HCl will release 1 mole of CO2. So 0.0285 of HCl will release 0.0285 of CO2, right? Mole of CO2, right?
Yes, ma'am.
Good, good. So if we know the mole of CO2, finding the volume will not be a problem. Okay, how do we find the volume? Chemistry students. How do we find the volume? 1 mole of any gas at STP has what volume?
22.4 dm cube.
Very good. So if you do proportion, you will get this. So the volume is 0.0285 times 22.4 dm cube. Okay? So find the answer, please. Press your calculator.
My God, 0.6384.
0.6384 dm cube. Approximately 0.638 dm cube. Remember, 3 significant figures. Any question here? Okay.
No, ma'am.
Please solve the remaining questions. I want to show you something. Please look at this. If you don't solve these questions, don't go to exam. I am telling you this carefully. It is my job to teach and explain something. It is your job to practice. Please, if you are solving this question, assume this to be sodium hydrogen carbonate. Okay? These are past questions that I got and twisted to suit the reagent we are told to prepare. So, assume this to be sodium hydrogen carbonate, okay? So that you will know the equation of reaction. And assume the volume we have been assuming all this while. Anywhere you see sodium carbonate, please take it as sodium hydrogen carbonate. There is another place. Okay. Wherever you see sodium carbonate, put sodium hydrogen carbonate and rewrite the balanced chemical equation. Okay? So solve all these problems before you step your foot in your school that you are writing an exam. I wish you well. So if you have any question, you can easily reach me, please. So let's move to qualitative analysis. I repeat again, make sure you solve all those questions before you go to the example.
Okay, ma'am.
Very, very important. You can solve those questions. There is no kind of question you cannot solve in the exam if you meet it. Okay, I need to save this answer. I need to save. Yeah. Okay, let's go to salt analysis, qualitative analysis. I'll try and move as fast as I can. Are you ready? Habibat, are you ready? Ademola, are you ready? Okay.
Yes, ma'am.
All right. Ariana, welcome. So let's go to salt analysis. We are going to focus only on what we are what we are thinking might, we already know the substance we are meant to test. So we just have questions around the substance. So this is not your WAEC question. These are likely questions. Okay. By the end of this, you should be able to carry out your qualitative analysis on the sample given. You should be able to identify the cations and anions present and draw a conclusion on the substances present in the sample. Okay, tomorrow you'll be given a mixture of a sample, and that sample contains 2 substances. So it will be a mixture of 2 substances. Okay, please don't bother about the color. Okay, the color may be white or blue because it wasn't specific. The substance given, let me mention the substance here, so because from the table you will still know. We were told to prepare, what's going on? To mix a reducing sugar with copper sulfate. So some teachers will go and get blue one, some will go and get white one. Either way, you still get the same result. So the mixture contains 2 substances, that reducing sugar and copper sulfate. What betide you if you go tomorrow and you write copper sulfate there for them, you will fail it because it is analysis for you to identify the cations and anions. So don't go there and say, I know the salt, so let me report directly. You are on your own, okay? Please, in qualitative analysis, we are identifying substances. We are not finding quantity. We are finding quality, identifying substances, okay? So for the purpose of this, the first thing you will be asked to do will be to dissolve to put the substance in water. The first thing you do most of the time is to make a solution of the sample. How do you do that? Put the substance in water, dissolve in water, okay? Now, the sample contains 2 soluble substances, so you are not going to get an insoluble substance, okay? So first, you prepare a solution of the salt or of the sample. That's the first thing you'll be asked to do. Then, the second step will be, the next thing you may do is to find cations, to find the cation present and the anion present. I don't know which one will come first, okay? But I need you to know one thing. If you are asked to test with sodium hydroxide or aqueous ammonia, aqueous ammonia means ammonium hydroxide, okay? If you are asked to carry out a test using sodium hydroxide or aqueous ammonia, know you that you are testing for the cations. Are you with me, class? Am I alone here? Wait, what is going on? Please, if you are with me, you indicate. I want to know when I am no longer in this class. Are you with me?
Yes, ma'am.
Okay. What is this? Come please. If you hear add sodium hydroxide to the solution, you are looking for the cations. If you hear add aqueous ammonia or ammonium hydroxide, you are looking for the cations. Okay. Now, the sample you are given contains a cation and then a sulfate ion. So if you hear we test sulfate ion with barium chloride and acid. So if you hear add barium chloride to the solution or to the portion of the solution and add acid, then you are testing for the sulfate ion. So you know what you are looking out for. Good. Then we have a reducing sugar we need to test. So please, for this reducing sugar, they may ask you to just heat the mixture that you added sodium hydroxide to, or they will ask for fairly solution. Anyway, I'm coming. Let's move first. Please, for easy memorization, the reagent I'm adding for test for cation, I'm adding it in this following order. Tomorrow, it may come, ammonium hydroxide may come before sodium hydroxide. You just need to know what it should be. So for the purpose of this class, I'm adding sodium hydroxide before this. Okay. Now, this is how I teach my students this with other ions, but for copper. When you add sodium hydroxide to any solution containing copper 2+ ion, it will give you a pale blue precipitate. If you add ammonium, I repeat, if you add sodium hydroxide to any solution containing copper 2+ ion in drops, it will give you a pale blue precipitate. If you add ammonium hydroxide or aqueous ammonia to any solution that contains copper 2+ ion, it will give you a pale blue precipitate. So both of them give you pale blue precipitates when you add them in drop in any solution containing copper ion. Okay. Now the memory tips I made is for in excess. Okay. So take a look at this. If you have a solution containing this and you add sodium hydroxide in drops, what you will notice is a pale blue precipitate. If you add in excess, that if you add more quantity of sodium hydroxide, please, if you are doing this tomorrow, the solution you should be using should not be more than 2 cm3. Just a little solution at this level. Nobody told you to go and measure. Just something small at the bottom of the test tube. The smaller the sample, the clearer the observation. Okay. There is no limit to excess. If they ask you to add in excess, you can even add till the test tube is filled and you shake. But in drops, just few drops. Okay. All right. So pale blue precipitate will be formed in drops. Then in excess, you will see something like this or something like this. Okay. If you add in excess, the precipitate will remain. Okay. You see something like this. The precipitate will be looking at you. It will not dissolve. Okay. Now, you may be asked to get another portion of the solution because you will prepare the solution. You add water to the sample and make a solution. So with your test tube, you'll be getting small solution. for your analysis. You get the first portion, carry out this titration, this analysis, please. You report your observation, you discard it, you get another test tube, you get a second portion and carry out this one. Don't worry, we are going to answer a sample question. So if you add ammonium hydroxide or aqueous ammonia to any solution containing copper ion in drops, you notice blue precipitate. Then if you add in excess, if you add more in excess before the precipitate will dissolve to give you a deep blue solution. Deep blue solution. So in excess of sodium hydroxide, precipitate is insoluble. In excess of aqueous ammonia, precipitate is soluble. That is why I use this as the memory tips. If you are testing for copper, the memory tips I use is copper ions. Copper ions. Insoluble in excess sodium hydroxide. Excess sodium hydroxide. Then S, soluble in excess aqueous ammonia. Are you with me, class? So the first thing you do if you go to your hall is to write down this memory tip in front of your answer script in case you forget under pressure. Are you with me? Are you with me, class? Are you with me?
Yes, ma'am.
Okay. Don't worry, we are going to solve a sample question. I'll still send the slide after this. Now, let's take a look at this sample question. Someone should read this for us. Habibat, this time around. Read this for us. Please be fast. Habibat, are you here? Okay. Who else? Can someone volunteer and read? Who else is here? Abibat has gone radio silent. Silence. Ademola, read for us. Ademola, read for us. Please be fast. Be fast, please. Okay. Arolua, please read for us. Unmute and read for us. Okay. Are you here? She just joined. Please read the question for us.
Yes, ma'am.
I'm waiting, please.
Credit, ma'am, is it the question or the instruction?
Read everything. I'll tell you where to stop.
Okay, ma'am. Credit will be given for strict adherence to the instructions, for observations precisely recorded, and for accurate inferences. All tests, observation, and inferences must be clearly entered in this booklet in ink at the same time they are made. C is a mixture of two substances, one organic and the other inorganic. Carry out the following exercises on F. Record your observations and identify the gas or gases involved. State the conclusions you draw from the results of each test. A.
Okay,
Put
pause. Okay, this is C, please. That's a mistake from my editing. Okay, now C is a single substance made up of two different substances. So C is a mixture of two different substances. Okay, so carry out this experiment and plot the table we are about to plot. Okay, Aroloa, continue. Continue.
Okay, ma'am. Put all of C in a beaker and add about 10 centimeter cube of distilled water. Stir the resulting. I can't see your screen. My network is bad.
Okay. Abuchi, can you continue? Thank you, Aroloa. You've tried.
Okay, ma'am. Thank you, ma'am.
You're welcome. Abuchi. Mother Abuchi. He is not here. Okay. Elizabeth,
Okay, ma'am, I can
please.
see it now.
Okay.
Stir the resulting solution thoroughly. Test the solution with litmus paper. B.
Okay,
To
let's
about 2
pause there.
centimeter cube of the.
Let's pause there first. The first thing they asked you to do is to make a solution of C, right? Make a
Yes,
solution
ma'am.
of C. So I need you to draw a table this way. Test, observation, and inference. Your inference column should be smaller. Test, observation, and inference.
Okay, ma'am.
Make your table bold and you number accordingly. Tell me when you've done that. Just test, write test, observation, and inference. Okay, Habiba said her speaker is not working. All right.
I've
That's
done.
fine. Okay. Okay. Now, the first question says, put all C in a beaker and add about 10 cm cube of distilled water. Stir the resulting solution thoroughly. Test the solution with litmus paper. We don't know what will come out tomorrow, okay? But we know the tests that are supposed to be, we are supposed to carry out. But we don't know exactly which one among them, okay? But one thing is sure, you must make a solution of the sample. Now, how do you report? Sample is a solid, so the sample is a solid. So you write C solid, okay, plus distilled water. Make sure you number this AI according to the question. When you write this, you write the observation first. It dissolves to give you a pale blue solution. Everything dissolves, and because you have Cu2 plus ion inside, that is why it gave you a pale blue solution, okay? Now, they told you that C is a mixture. A mixture. C is a mixture, okay? And this mixture contains soluble substances. That is why they dissolve. And because it contains copper ion, the mixture gave you a blue solution. So please, this is what you report. For every other solution, colorless solution, you just say C is a mixture of soluble substances. That is why we have a solution. Okay, no solid. It wasn't like chalk, it was transparent. It looks like this. Okay, now because the solution is colored, it has given us an idea of the cation present. Okay, please, as long as the solution is colored, you must add, to be on a safer side, you must add C is a mixture of soluble substances. Blue solution due to copper 2+ present. Okay? This only is for dissolving. Is this taken, class?
Yes, ma'am.
Good. Remember, if this dissolves to give you a colorless solution, we just report soluble substances. But because we have a blue solution, okay, you tell us that C is a mixture of 2 soluble substances, okay? And blue solution is due to the presence of copper 2+. Because in WAEC Magad, if you have a blue solution when you dissolve, you must tell them the ion you are, not even blue solution, color solution. You must tell them the ion present that you are suspecting. If it is green, you must tell them that is ion 2. If it is yellow or rust, you tell them ion 3. Okay? Now, still in this same question, they said, test the solution with litmus paper. Then you write plus litmus paper in the next line. So under this next line, you tell us your observation in the next for the litmus paper, okay? Because of the nature of the salt, the solution will turn blue litmus paper red, a very light red, please. So look out for it if you are asked. If it turns blue litmus paper red, what does it imply, class? What does it imply?
Means it's acidic.
Very good. So we will now report our inference from this observation. We will say the solution C is acidic. Please don't tell them solution C is acid. You don't know what it is. Just tell them that the solution is acidic. It may be water that they just added a drop of acid. Just tell them that solution C is acidic. All right. In case they ask you to fill the container, because the dissolving of one of the salts, the dissolution of one of the substances is exothermic, okay? So if you are asked to fill the test tube, you are likely to notice that the test tube is warm or hot, okay? So the test tube feels hot to touch. This is the experiment that has been carried out, okay? So even if you don't notice this, there is a problem from your end because this experiment has been carried out. So you report this even if you did not notice it. Plus feel, the test tube feels warm or hot to touch. What does it imply, class? When you carry out an experiment and the test, good. Dissolution of C is exothermic. That's dissolving C is exothermic. That's the reaction. Dissolution of C is exothermic. Please, dissolution of C, or you say dissolving C is exothermic. Any question here before we move to question B? Any question here?
No, ma.
Okay, please note this. Note this. Tell me when you are ready, then we move. Elizabeth, I've not been hearing your voice. Is Madabuchi back here? Okay, Marvel, I've not heard your voice. Are we ready?
Yes, ma.
All right. So let's go back to question B. Question B. So who is reading for us? Continue, please. We don't have time. I would have called someone else. Aroloa, please continue.
Okay, ma. For question BI, to about 2 centimeter cube of the solution, add barium chloride to solution followed by hydrochloric acid. Then for
Good. Pause.
B2,
Pause. So about 2 cm cube of the solution. So you have made the solution maybe in a beaker or in a boiling tube. Boiling tube is the big test tube. That's what you call boiling tube. Okay. Now you have made the solution. What you need to do is to get a test tube and get a little quantity of that solution into the test tube. Just small quantity, just like a hand, the tip of your index finger. Okay. That quantity is about 2 cm cube. Now, we are told to add barium chloride solution followed by HCl. If you are asked to add barium chloride solution followed by HCl, what ion are you testing for? I say something about this. Tell me the ion you are testing for. Before we move, who should I call now?
Chlorine ion.
What?
Chlorine ion.
Chloride ion. Okay.
Yes,
Any other opinion? I made mention of the ion you use barium chloride to test. Any other opinion? You've forgotten so soon? Okay. Now, we can't use barium chloride to test for chloride ion because chlorine is already part of the reagent. So you cannot actually use it to test for chloride. You are testing for the ion in the sample, so you cannot use barium chloride. We use barium chloride to test for sulfate ion. I think I said something like that here. For sulfate ion identification, test with barium chloride and HCl acid. So once you hear add barium chloride followed by HCl acid, you are testing for sulfate ion. So let's go to our table. BI. Table BI, you number accordingly. Table BI. So you number this as BI. Please, this is not part of what you are writing. This is for us to see what we are doing. So BI, is it BI? Yeah, BI, sorry, BI. aqueous means solution of C. You can write solution of C, okay? Or you write aqueous, okay? Please don't write C solid. If you write C solid, the problem is that you will fail even the observation, because in the MATGAD, if your test is wrong, your observation is wrong, even if it looks correct. So if you write C solid, you are in trouble. So write solution of C or C aqueous, because the test is on the solution, not on the solid. Okay, C aqueous plus barium chloride solution plus dilute HCl. First of all, this test is very, very clear. It is not something you doubt. It is always clear when you are doing it in the lab. Always obvious. When you add this solution to a blue solution of C, before you will notice a white precipitate, something that looks like this. Because the precipitate is white, as in, and it is in the solution, the blue solution, you will notice it like this, okay? You will not notice it as a colorless and white substance. No, you will notice white precipitate, okay? You see white particles, white particles in the blue solution, okay? When you notice white precipitates, when you add this, there are ions that can give you white precipitate when you add barium chloride, and they are carbonate ion. Please, if you don't have charge on this, you are losing the mark. We are testing for ion, okay? So carbonate ion or sulfite ion, 2 minus, or sulfate ion present. Even sulfide will give you this, present. Barium chloride with C will give you white precipitate. If it gives you white precipitate, these are all the ions we are suspecting. Please don't go straight and write sulfate ion, even though you know a sulfate ion, because all these ions will give you white precipitate. Remember, you are carrying out this test as if you don't know the ions. Okay? Now, let me tell you, in WAEC, if you report only sulfate ion, you are losing the mark for the first, for this first observation. Because what confirms sulfate is the last test, which is this. Okay? So for white precipitate, report carbonate ion, sulfate ion, and sulfite ion, and sulfate ion. Then plus dilute HCl acid. If you add dilute HCl acid in this white precipitate formed, if it is carbonate ion, the white precipitate will dissolve, and you will notice effervescence, that's bubbles. If it is sulfite ion, which is this, it will dissolve, and you will notice bubbles coming up. But if it is sulfate ion, the precipitate will be looking at you. The precipitate will not dissolve. So, from what you'll be given tomorrow, you are expecting the white precipitate to remain. So the white precipitate is insoluble, okay, in dilute HCl. That is when you are now going to confirm that the ion is sulfate ion, okay? Is this taking class?
Yes, ma'am.
Good, good. So if they ask you to put barium chloride, then dilute HCl, you report the test this way. White precipitate for barium chloride first, then precipitate insoluble for dilute HCl. But if they said you should add to the sample of C, you should add HCl and barium chloride at the same time, just report white precipitate and report sulfate ion, okay? But if they said this followed by this, if they said this followed by this, you must report your observation for this and report your observation for this. Okay, any question?
No, ma.
Ma.
All right. All right. So put this down. Then we'll move. How many minutes do we have? Okay, we may meet up. Put this question. Put this down. Ready?
Yes, ma.
Okay. Now, BII. BII says to another 2cm cube portion of the solution. Oh. To another 2cm cube portion of the solution, add sodium hydroxide in drops, then in excess. Then my question is, when you are asked to add sodium hydroxide in drops, what are you testing for? Someone should tell me. What type of ion are you testing for? I mentioned it earlier, so I need someone to tell me.
Copper ion. Copper ion.
Okay. Okay, good. Any other opinion? Any other opinion? Okay. I said that when you are asked to add sodium hydroxide in drops, you are testing for a cation. Okay? Cation means positive ions, right?
Yes, ma.
Good. And in our own case, we are testing copper 2+ ion, right? So let's go to our observation. So BII, you number accordingly. BII. Okay. So the second portion, add sodium hydroxide. So C aqueous. This is a fresh portion now that you get. C aqueous plus dilute sodium hydroxide in drops. Remember, I told you will notice a blue precipitate. So a pale blue gelatinous precipitate. Are you with me?
Yes, ma.
Gelatinous. The precipitate looks like as if you put let's say crushed melon, that's crushed egusi in a solution. It looks oily. The precipitate looks oily. It doesn't look like chalk. That is what we mean by gelatinous. Okay. So a pale blue gelatinous precipitate is formed. So you notice something like this in drops. In excess sodium hydroxide. Remember our memory tips, copper inks. So in excess sodium hydroxide, what would we notice about the precipitate, class? What should be our observation in the precipitate in excess? I'm
It will
waiting for
be
you. It will be insoluble. Wonderful. It will be insoluble. So, first of all, we noticed a pale blue gelatinous precipitate formed. When you notice a pale blue precipitate, automatically your inference is copper 2+ ion present. Okay? Then, In excess, we notice that the precipitate is insoluble. Okay, the precipitate remains. Then you still confirm, you still report copper 2 plus present. Now, the mixture, remember I told you were given a mixture of C. So the second substance, you may not even, anyway, let me come first. The second compound in that mixture is likely to affect this reaction if you allow it to stay for a while. So I don't know whether they will tell you to leave for it to stand. They will either tell you leave the solution to stand for a while or you heat. Okay. First of all, precipitate is formed and the precipitate is insoluble. So if you allow the precipitate to stay for a while, you will notice that a reddish brown or brick brown precipitate is formed. Precipitate is formed. Or if they either tell you to leave it for a while or they will tell you to heat it, to heat the precipitate formed. If they tell you to heat it, you will notice that immediately. If they tell you to leave it to stand for a while, just in few seconds, you will notice the precipitate you noticed here turning red-brown. And that is when we'll now report precipitate turns to brown-red or red-brown on standing. Okay? Biology students, I need you to answer this question. If you are testing for the presence of a reducing sugar, example, glucose or fructose, you'll be asked to put Ferlin solution. Ferlin solution contains copper 2 plus and sodium hydroxide. So if you add the Ferlin solution to the starch, to the reducing sugar, what are you expecting to see? Do you do that in biology?
It will give us a brick red color change.
Good. Brick red color change. And that Ferlin solution A is copper sulfate solution. Ferlin solution B is sodium hydroxide and potassium acetate. Sodium, potassium, okay. I think it's not acetate, another acidic, another organic salt, okay? Good. Now, you see that this Ferlin solution is just like what we have here. Are you with me? Are you with me? Hello, class. Are you with me?
Yes,
Yes,
ma'am.
Our solution contains copper 2 plus, and we are told to add sodium hydroxide. So indirectly, we are preparing Ferlin solution. Okay, that was why when we left the precipitate form on standing, or when we heated it, we noticed a red-brown precipitate. Okay, so this is the test for a reducing sugar. Okay, the test for a reducing sugar. Okay, so if you notice any brick red or red-brown precipitate tomorrow, you report reducing sugar present. My dear, you don't know the sugar. You don't know whether it's fructose. You don't know whether it's glucose. If you write glucose here, you will fail it because fructose will give you the same observation. Which other one will give you the same? All monosaccharides will give you the same observation, including maltose. Maltose is a disaccharide. to give you the same observation. So simply say a reducing sugar present. Okay. What actually happened is that the sugar in this is oxidized. The sugar in this went and reduced copper 2 plus. This brick red precipitate is copper 1 ion. So it reduced the copper 2 plus, which is the blue precipitate, to copper 1. Okay, that is why we call it a reducing sugar. Are you following, class?
Yes, ma.
Yes, ma'am.
Okay. Okay. Any question? Any question?
No, ma.
All right, put it down. Put it down. Please tell me when you are ready, please. Let's move faster.
We are ready, ma.
Okay. Then BIII. BIII. Let me go back to that question. BII. III says to another portion, add aqueous ammonia in drops and then in excess. Elizabeth, when you are asked to add aqueous ammonia in drops, what type of ion are you testing for?
Anions.
Anions. Okay. Any other opinion?
A cation.
A cation. A cation. Look at this. I made sure I displayed this before moving. Please make sure you go through this again after this class. This is a summary of all that table we are preparing, all the tests we are doing. For cations identification, you test with sodium hydroxide and with aqueous ammonia. So let's go back to our test. So C solution plus dilute aqueous ammonia in drops. Remember, we told you that both sodium hydroxide and ammonia will give you a pale blue precipitate in drops. So we have a pale blue gelatinous precipitate formed. So what should I report here as the inference?
Ammonium present.
What?
Copper 2 ion present.
Good. Copper 2 plus ion present. Copper 2 plus present. Okay. Then in excess, who can tell me the memory tips I gave you? Give me that memory tip. Let's check. Even though I have that in table, but I need the memory tip. I'm waiting, please. Be fast. The memory tip I told you for copper ions. Test for copper ion. Or you type if your mic is not working. For those people whose mic are not working, tell me the memory tip I gave you. I'm waiting for you.
Ma, is it when it gives a blue color or a blue
When you
precipitate?
add sodium hydroxide and ammonia, I gave you a memory tips for that. Oh, you don't remember?
Yes, ma'am.
Okay. In excess sodium hydroxide, precipitate is insoluble. That is the meaning of in. In excess ammonia, precipitate is soluble. That is the meaning of S. Soluble. So look at this. C solution plus dilute aqueous ammonia. We have pale blue precipitate formed, copper present. Then in excess, the precipitate dissolves. The precipitate dissolves to give a deep blue solution. Initially, the precipitate you will notice would be something like this, please, but not transparent, okay? Please transparent, okay? It will not be transparent. You notice heavy blue precipitate here. Then if you have this quantity, please, in your test tube, pour it away or reduce it to this quantity before you add excess. If not, you'll be wasting your ammonia. When you have this quantity of precipitate, reduce it to this point, then add excess ammonia. The whole precipitate will dissolve. A very beautiful deep blue solution will be formed. You will notice this if you did your experiment. Wow. Very spectacular. You will notice a deep blue precipitate. You will be sure that it is deep blue. It is very obvious. Okay, so you don't just say the precipitate dissolve. You will tell us what it dissolves to. Okay, the precipitate dissolves to give us a deep blue solution. So the mark is here and here. Good. This is the confirmatory test for copper ion. So at this point, you write copper 2+ confirmed. Okay, so if you have a test using aqueous ammonia, this is how you report it. Any questions?
No, ma'am.
All right, please put this down. Tell me when you're ready. Ready?
Ready.
Okay. All right. Now, nobody is sure. The last test we are going to do is this. We are not sure if we'll be given this, okay? Because this will give you the same result. This particular last test will give you the same result. So no one knows if you be asked to add Fehling solution, okay? But if you are asked to, okay, know that you are expecting a brick red coloration, all right? If you're asked to add Fehling solution to a solution of C, then you will notice light blue precipitate. Remember I told you that Fehling solution A contains copper 2+, okay? And solution B, Fehling solution B contains sodium hydroxide. So the reason why you will notice a pale blue precipitate is because sodium hydroxide will react with the copper ion here, okay, or the copper here, okay? That is why the first thing you will notice is a pale blue precipitate, okay? Then +1, then +1. If you warm, you will now notice the red brown precipitate, okay? So for pale blue precipitate, just write copper 2 plus present. Then +1, precipitate turns brick red or yellow brown. You now report a reducing sugar present. A reducing sugar present. Now listen. This experiment tomorrow will be difficult for you to identify. Okay? I'm saying that from experience. The reason is this. The sample contains copper ions. Okay? And Fehling solution contains copper ion. So the first one component of the sample contains copper ion. The second component contains a reducing sugar. Okay? Now, Fehling solution and sodium hydroxide is meant to cause the reducing sugar to reduce copper ion here. But because we have copper ions too in the sample, we are going to have excess copper ions. So instead of noticing a very brick red precipitate, you may notice a yellow brown precipitate because the copper ions are so many. So the reducing sugar will not be enough to reduce all the copper ions. So the little it will reduce, you will see the color this way. Are you with me, class?
No, ma.
Okay. You know that if you have a reducing sugar, let's say a sample B contains, let me say, glucose. And you are asked to add Fehling solution. Okay? Fehling solution contains Cu2 plus and sodium hydroxide. Are you with me?
Yes, ma.
Good.
Yes,
Now,
ma'am.
good, plus heat. When you add this to this, okay, this glucose will reduce the copper ion here to copper 2 plus. Copper 2 plus is blue in color. That is why Fehling solution A is blue in color. So if you add this Fehling solution to glucose, it will convert copper 2 plus in the Fehling solution to copper 1 plus. It is the copper 1 plus that is the red precipitate. Are you following?
Yes, ma'am.
Are you with me?
Yes, ma.
Good.
Yes, ma'am.
So if you are adding this directly to the glucose, it will give you a red precipitate because the glucose will reduce copper 2 plus to copper 1. Copper 2 plus is blue in color. Copper 1 is red precipitate. Okay. Now, we are not adding Fehling solution to glucose. We are adding Fehling solution to a mixture that already contains copper 2 plus and a reducing sugar, let's say glucose. Okay. So remember, Fehling solution has copper 2 plus. Sample has copper 2 plus. So we have too many copper 2 plus that glucose will act on. Are you with me?
Yes, ma'am.
So the glucose will not be enough. If it reduces all the copper ions in the sample, the one in the Fehling solution will still be remaining. That is why instead of having a red brown precipitate, you may see a yellow brown precipitate. So each one, any one you see, please, the inference is a reducing sugar. Are you with me?
Yes, ma'am.
Okay.
Ma, the
Is that
glucose,
okay?
is it the glucose? Is it the content, right? Content of Fehling solution?
No. We are suspecting glucose in C, inside C. Okay? Remember, I told you that C is a mixture of two substances, right? I need to know if you are hearing me. It's a mixture of two substances, right?
I'm hearing you. I had a bad network. I weren't
Okay.
when you
Okay. So remember we said that C is a mixture of two substances. So we've been doing a test, we've been carrying series of tests, and we discovered that one of the ions in C is copper 2 plus. Okay. One of the ions in C, another ion in C is sulfate ion. Okay. So now we carried out another test and we noticed a brick red precipitate showing a reducing sugar. So definitely the second component of the mixture C is a reducing sugar. Are you following?
Yes, ma'am.
Yes, ma'am.
Very good, very good. So I think, I don't know for sure, but I don't think this last test will come out because this test will take care of the last test. This particular test now will take care of the last test. But if it comes out, please just report accordingly. Are you with me, class?
Yes, ma'am.
Yes, ma'am.
All right. All right. Any question?
Please, ma'am, scroll down. I want to screenshot the previous.
You want to do what?
Screenshot the previous slide of the
Is it this one?
from the beginning of this.
Okay. I will send the slide to you. But let's finish. If I finish this, we can go back if you want to take a screenshot. Okay. So please, let's first of all put this down. If you're taking a screenshot, take a screenshot. Let's move. Let me know when you're ready.
Start from the first.
Okay.
From the first
Any
one.
question?
From the first I. Let's start.
Hi.
I.
That's this one.
Yes. 2.
We have a lot you haven't taken a screenshot. It seems you left and came back because there was a time I called your name and you were nowhere to be found.
Oh, my data finished.
Eh?
I went low data.
Hey, yeah, sorry. Don't worry. I will go back to the first slide for you to screenshot, okay? But first, let's round up, okay? So are we ready now?
Yes, ma'am.
Are we ready?
Yes, ma'am. Yes, ma'am.
Okay. So from all this we've done, from the tests we've done, please tell me the cation we noticed. Fast.
Copper 2 plus ion.
Good. Copper 2 plus ion. Tell me the anion we noticed. I'm waiting. The
Sulfate.
anion, good. Sulfate ion.
Yes,
Good.
ma'am.
Tell me another substance we noticed.
Carbonate 2 minus ion.
Really? We did not notice this. We suspected this because of white precipitate. So what confirms it? We confirmed is this. So this was not in the reaction. This was not in the substance. Okay? Are you with me?
Yes, ma'am.
Good. These are what we suspected. Okay? But from our suspects, we confirmed sulfate ion. So sulfate ion is the anion, and copper present is the cation. But there is something else we noticed apart from these two ions. What is that?
A reducing sugar.
A reducing sugar. Very good. A reducing sugar. A reducing sugar. So what it means, from this, we can conclude that C is a mixture of copper sulfate and a reducing sugar. Are you with me? Are you
Yes.
following?
Yes, ma'am.
So that should be our conclusion. Sample C is a mixture of copper sulfate and a reducing sugar. Please, a reducing sugar. Never you write glucose tomorrow. If you do, you're on your own. Hmm? Any question?
No, ma'am.
All right. We have come to the end of this. So, in summary, you are likely to test for the presence of copper ion tomorrow and sulfate ion and a reducing sugar. It doesn't matter whether you know it or not. The most important thing is, can you report this accordingly? If your test is wrong, they will mark your observation wrong and your inference wrong. So please get your test right so that your observation, you will get your mark for your observation and your mark for your inference. Okay? And I say again, practice, practice, practice. I am just a chat away if you have any confusion. Okay? So I wish you the best. I wish you the best in this exam. Good luck to
Thank
all of
you.
you. Yeah, you have
Amen.
tried. May God bless your efforts.
Amen, ma'am.
All right. See you when I see you.
Good night, ma'am.
Good night. I will send the notes to the admin now. See you later.
Okay.
All right, which I hope you heard me. Please collect the